Hi students, good morning students. Observe the next question from JEE Mains Structure of Atom 2019 question number 21. Observe here. Which of the graph shown below does not represent the relation between incident light and electron ejected from metal surface? Which graph does not reflect? You know that already photoelectric effect, the formula. What is that? Incident light energy h nu is equal to threshold energy h nu naught plus kinetic energy. This is the formula, you know that already. So kinetic energy is equal to what is that? H nu minus h nu naught. So observe here from this is incident light frequency, this is threshold frequency. This is the kinetic energy of the ejected electron. So kinetic energy of the electron increases with increase in frequency of incident light from that formula. So kinetic energy is directly proportional to frequency. Okay. Based on this graph, which graph does not represent this relation? Here the kinetic energy of ejected electron increases with the energy of the light frequency. Kinetic energy of electron, frequency of light increases. Here the frequency increases, kinetic energy increases. This is frequency relation based, this is energy relation based. You know that already frequency and energy relation is directly proportional. So energy increases, frequency increases. Here in this graph is moving from the origin. So origin means y is equal to mx. This is not from the origin. This graph represents y is equal to mx plus c. Next, observe here kinetic energy of electron is independent on intensity of light. Basically, intensity and kinetic energy relation. Intensity increases, kinetic energy doesn't change. Kinetic energy of electron doesn't change. That is independent on intensity. Intensity is nothing but brightness of the light, na? Intensity is nothing but brightness of the light. For suppose here, observe here, the brightness of the screen is less, intensity is less. I am increasing the intensity. Observe here, brightness I am increases. Here the brightness I am decreases. Lower brightness, this is higher brightness. At lower brightness, how much kinetic energy is present? Higher brightness also kinetic energy of the electron is same. But the number of photons delivering from the screen is different. Here the number of photons delivering from the screen is more. Number of photons delivering from the screen is less. Intensity increases, number of photons increases. Intensity decreases, number of photons decreases. But kinetic energy of the electron is same. Speed of the electron is same. That is the difference between with the kinetic energy and number of photons delivering with the intensity. So here the graph B is the incorrect option. Next question, observe here students. Ejection of the photoelectron from metal in the photoelectric effect experiment can be stopped by applying 0.5 volts. When the radiation of 250 nanometers is used, incident light wavelength. The work function of the metal. Work function of the metal is asking. So work function of the metal is asking, this is work function, this is incident light, this is the kinetic energy of the electron, that is nothing but stopping potential also. So first find out the incident light energy h nu is equal to h nu, that is nothing but hc by lambda. H value how much? You know that already, Planck constant value. C is nothing but velocity of the light. Wavelength is the incident light wavelength. How much is given here? 250 nanometers here. I am substituting these values, then we'll check the answer. After substituting all these values, Planck constant value, velocity of the light and wavelength of the light. Here, what is the unit is present here? Joule is present. 1 joule is equal to 1.602 into 10 power minus 1 electron volt. Sorry, 1 electron volt is equal to 1.602 into 10 power minus 19 joules. So in the place of joule, I am replacing with electron volt. So 6.626 into 10 power minus 34, 3 into 10 power 8 meter per seconds. 250 into 10 power minus 9 meters by 1.602 into 10 power minus 19 electron volts. So 1 joule, in the place of joule I am replacing this value. 1 joule value 1 by 1.602 into 10 power minus 19 electron volts. In the place of joule I am replacing with this value. After simplifying all these values, we are getting 4.96 electron volts. So what is asking here? This one is asking. So H nu is equal to H nu naught plus kinetic energy na. So kinetic energy, stopping potential, how much is given in the question? 0.5 volts. So H nu naught is equal to 0.5. H nu value is 4.96. So 4.96 electron volt plus 0.5 volts. So this is nothing but stopping potential now. Stopping potential expressing in electron volts. So what is the answer? 4.96 minus 0.5, 4.46 electron volts. Approximately how much? 4.5 electron volts, students. So stopping potential value expressed in terms of electron volts. Okay na students? Next question. Observe the question number 23. Excited hydrogen atom emits light in the UV region 2.47 into 10 power 15 Hz. What is this frequency, the energy of a single photon? So incident light photon energy is asking. Incident light is equal to H nu. Energy is asking. So H value we know that, and frequency value also is given. So 6.63 into 10 power minus 34 joule seconds into 2.47 into 10 power 15 hertz. So what is here? 1 hertz is nothing but what? 1 second inverse na? 1 hertz is nothing but 1 second inverse. So 6.63 10 power minus 34 joule seconds, 2.47 into 10 power 15 second inverse. So second inverse cancelled. What is remaining here? 6.63 into 2.47, 10 power minus 34, 10 power 15, 10 power minus 19 is remaining. Units, what is remaining? Joule is remaining. So 6.63 into 2.47 value how much? After simplifying the value, you are getting 1.64 into 10 power minus 18 joules. Option C is the correct option. After simplifying this value, you are getting this value. So 1 hertz is equal to 1 second inverse. That unit conversion is important. This is the incident light energy. Next question, students. Observe the question number 24. Ionization energy of gaseous sodium atoms is 495.5 kilojoule per mole inverse. The lowest possible frequency of light that ionizes sodium atom. That is same formula. E is equal to H nu. This is for one photon. 1 mole of photon Na H nu. So frequency is asking. Ionization energy is given 495.5 kilojoule per mole. Per mole is asking, that's why taking here Avogadro number 6.63, 6.602, 6.022 into 10 power 23, 6.626, 10 power minus 34, asking nu. So nu value is how much from this question? So this is the relation. So find out the nu value. So nu is equal to, actually here students, kilojoules is present, here the joule is present. So I am changing that kilojoule value in terms of joules. So 1 kilojoule is equal to 10 power 3 joules na. So frequency we needed 495.5 into 10 power 3 joule per mole by 6.022 10 power 23 6.626 into 10 power minus 34. Now simplify all the values, then you are getting what is the value. Once check, students, this is the formula. Once check that value. After simplifying all these values, you are getting almost 12.4 into 10 power 14 second inverse. So frequency units second inverse na. So 1.24 into 10 power 15 second inverse. So check that option, which option is the correct option. So option D is the correct option. Simplifying these values, that is important thing for a solution.